let's try to evaluate the indefinite integral 1 over the square root of 1 minus x squared dx. And you might try something like u substitution, but you'll find out that it doesn't get you very far with this integral. And so instead we will do something called trig substitution. And the whole idea behind trigonometric substitution is to substitute for x so that with a trig function, so that this might simplify using some trig identities, and maybe it'll turn this entire integral into something that we can actually integrate. And so the trig substitution that we'll do, and the big clue here is when we see this 1 minus x squared. In fact, if we ever see an a squared minus an x squared, so 1 is 1 squared minus x squared, it's a pretty good clue that we would want to substitute with something times sine of theta. In this case, if we just make the substitution, if we say that x is equal to, let me do it over here, x is equal to, if we say that x is equal to sine of theta, then what we have under the radical right over here is going to become 1 minus sine squared theta, which is cosine squared theta, and then we can take the square root of that, and that might simplify all of this business a good bit. And we just want to make sure that we're not artificially constraining our x more than what the domain here would otherwise constrain our x. So if you look over here, the x cannot be, the x right over here has to be less has to have an absolute value less than 1. Or another way of saying it, the domain right over here, x has to be greater than negative 1 and less than positive 1. If it was 1, then the denominator right here is going to be 0. If it was greater than 1 or less than negative 1, then all of a sudden you're going to have a negative under the radical sign. So already our domain is constrained for these values of x. So if we say x is sine theta, this actually allows x to be anywhere between negative 1 and 1, including negative 1 and 1. So we're not constraining x more than the domain has already constrained it. Since we're going to have to unwind the substitution later on, let's also define theta in terms of x. So let's say, and in a way that's not consistent with this top statement. So let's also say that theta is equal to arc sine, or inverse sine, of x. And what does this do? Well, this actually constrains what our theta is going to be. If I draw a unit circle, my best to draw one. So this is my unit circle. And if I come up with a particular x, that's going to be essentially the potential sine value. Arc sine is going to give an angle that is in the first or fourth quadrant. So if we say that this is our sine, if this is our x, then the arc sine of x is going to be this angle, not this one out here, the second quadrant. If we say that this is our